Thanks everybody for being here at ShmooCon number 20. Please give a warm welcome to Andy Sellars and Michael Specter with Software Screws Around and Reverse Engineering Finds Out.
Thank you very much. It's kind of a nice juxtaposition between the last talk and this talk, because the last talk was a discrete, fun, and interesting project that had to involve some lawyers at some point, whereas we're making a bunch of macroscopic observations about the greater relationship between hackers and lawyers, and in particular lawyers that work for the government. So we're going to actually start with what I think is a fairly obvious observation for this crowd, but just get the ball rolling. It's really hard to know what software is up to in matters of privacy and security. Even in its most basic forms, of course, it is incredibly complicated with how it is coded and compiled and run. Key components these days of a lot of software are cloud-based, so you can't actually get access to the software that you might hope to examine. And a lot of software that's even on our devices gets updated all the time without our knowledge, without our participation. And all of that was true before we started to see a lot more software entering our daily lives that has these extraordinarily complicated coded components, these sort of generative AI and other things like that. So if we want to understand what software is up to as consumers or as researchers, or indeed as the government seeking to regulate software, we're off to a really bad start even from the get-go. And that's actually true before the law comes in. And I hate to say, as the lawyer, law often makes things worse. A long line of scholarship going back over half a decade now has talked about how the way the law protects software, and in particular the doctrine of trade secrets, makes it really difficult to use the law to figure out what software is up to. So if you want to send a FOIA request and learn about a bunch of stuff about how the government uses software, you're going to come up against the trade secrets exemptions in FOIA. If you want to do civil or criminal discovery, Rebecca Wexler has this amazing article talking about how that actually stops a lot of access for criminal defendants, for example, in software. If you want to try and do different projects with software, you might find a misappropriation of trade secrets claim coming your way. And it even gives legal arguments for software vendors to resist calls for transparency in software, asserting the sort of property right in the software itself as a regulatory taking. So this is a complicated issue, and an issue that actually brought Mike and I together. So hello, my name is Andy Sellars. I'm a partner at a brand new public interest technology law firm called Albert Sellars LLP, alongside the great Kendra Albert, which I know many of you know. For the past 9 years, I've taught at Boston University School of Law and run a law clinic in partnership with BU Law and MIT that represents students when they do interesting, provocative projects in technology, which is how I got to know Mike. Mike was a PhD student at MIT. He is now an assistant professor at Georgia Tech, working on systems security, applied cryptography, and tech public policy at the amazingly named Specter Lab, which just sounds so cool. And about 5 years ago, Mike and some of his colleagues were investigating a piece of voting technology that was going to be piloted in the 2020 primaries. They were concerned about the company's claims that this particular piece of software, which was going to allow you to vote through your smartphone using the blockchain, which if you know anything about voting security or smartphone security or the blockchain, you might already be concerned as well. So he and some friends of his took it upon themselves to reverse engineer the software, did some static and dynamic analysis, found a bunch of serious issues in the software, and then my students, Quinn, John, Eric, and I worked with Mike and his team to disclose this vulnerability to the affected elections officials and to the software vendor themselves, all through the at time brand new Cybersecurity and Infrastructure Security Agency. Those pilots were suspended before they could be used in a way that might have caused some harm. We're tremendously proud of this work, Mike and I, but also a little surprised that this is how the world works. That is to say, do we really just leave it to graduate students working over their winter break to take it upon themselves to examine software playing critical roles in our democracy? And we wanted to better understand the relationship between independent research and how the government is able to hold software accountable. And I'll let Mike take it from here.
Thanks, Andy. So if we were to have a TLDR of this entire talk, this is our argument, right? Adversarial independent research is a necessary precursor to good security. And we actually have receipts. And those receipts come in two forms. The first, we're going to discuss a little bit of economic theory. And the second is we're going to provide you a little bit of empirical analysis, which is super exciting. So let's start with the economic theory here. The first thing I want to tell you about is that security is not just a technical problem. I'm sure most people, I'm sort of preaching to the choir, But like, despite years of research and development, many sort of straightforward protections are just not used. Attacks are often the result of foreseeable and preventable failures. And in general, there's a bunch of goals that are outside of simple policies. To quote Phil Rogoway, a cryptographer at UCSD, as a cryptographer, you can ignore this landscape of power and all the political and moral dimensions of our field, but that won't make them go away. It'll just tend to make your work less relevant or socially useful. So we want to embrace all of these principles. And I think the core problem in a bunch of security issues is incentive alignment. In particular, we are dependent on real-world vendors. These vendors have competing interests, right? And have a fiduciary duty to their shareholders, often. And in that, they must make more money. As a result, this is largely a consumer protection issue, and we should treat it as one. And what I want to introduce you to today is this concept that software is actually, in particular software security, is a credence good or a credence quality. And what do I mean by that? Well, in economics, there's this concept of an information asymmetry problem. And this is a situation where the purchaser of a product just knows less about the product than the seller. And importantly, even if the seller wanted to, they cannot actually prove the value of that product. To illustrate this, economists actually split products up into these 3 different groups by the level of information asymmetry involved. The first level, which is the simplest, is this idea of a search good, which is just a product that you actually just know the value of before you actually purchase it. And a good example of this is a nail, right? What do you do when you go out and purchase a nail, right? You're not going to look at online reviews for nails, right? There's no nail reviewer. You're just going to go out and buy a nail. You know its freaking melting point, its length, everything else before you even buy it. An experience good is probably what you're all used to here, right? Is that it's a product that you can only know the value of after you buy it. And the canonical example here is like a used car. So if you buy a used car, there's probably something wrong with it. You don't know what it is. And even if the seller wanted to, they can't really prove to you that that problem doesn't exist. So only after you've used it for a few years or months, then you actually find out what the problems are that need to be repaired. And the final one, which is the most important one here, is this credence good. And it's a thing that you can't know the value of without actually some expert analysis. And a good example of that is doctor visits. You don't know whether or not you are given a treatment that is more invasive or more expensive than what is actually fully necessary. Or a car mechanic, very similar vibe. And we would argue that software security is actually in this bucket. And the TLDR here, if you don't want to go off and read all these papers, is that the consequence of a credence good market is that when users cannot determine the value of a product's quality, the market's dominant strategy is actually just not to invest in it. As a result, there's chronic undertreatment. And this is not a new concept. As you can see, the paper that introduces this concept was in the 70s. So we've known about this kind of problem for a really long time. Luckily, there's a number of methods that are commonly used to regulate these kind of goods, these kind of products. This includes introducing liability, which just says that you can't undertreat me without risking your own hide. I can sue you for that. Another one is labeling and standards, right? So you might imagine if you've ever seen fair trade on a product that actually has defined meaning. And if you're not actually adhering to those defined meanings, they can sue you. A really good example was very recently the White House introduced this thing called the US Cyber Trust Mark, which is meant to be that kind of standard. When you affix it to a product, that actually means a thing. And finally, there's transparency and verifiability, which is just saying, hey, I can actually look at the thing and determine whether or not this is of the correct value. So what's interesting here is that we don't really have liability, right, as evidenced by the terms of use that I posted up there. Or so how do you actually end up doing this is you actually have labeling and you actually enforce that labeling. But the general problem with labeling, right, these are all real things that have existed in privacy policies that I've looked at recently, except for one. You can probably guess which one. And it's not the Trust Me Bro, unfortunately. Yeah, anyway. So the real question here is actually how does any of this get enforced, right? Turn that back.
Yeah, and I imagine that most of this room already knows that there can be this story that emerges between the government and hackers, where an independent researcher takes it upon themselves to discover some sort of issue in software. They tell the world about it. The government learns about it because the rest of the world found out about it, and then that sparks an investigation into the company. This is a story that repeats itself very often. I imagine several of you, in fact, I can see at least one of you that I know has actually had exactly this story play out with their own research. What Mike and I wanted to study, though, is exactly how often does this actually happen? And we are actually releasing right now for the very first time a data set which we've pulled together where we try to start to measure this phenomenon. Thank you. I'm so glad a data set gets an applause. So you can go visit FTC Reverse. There's no dot there, by the way. ftcreverse.engineering. Thank you, Mike, for the URL. And dig into the data set that we constructed. Let me tell you a little bit about it. So we decided to take a look at the Federal Trade Commission. The FTC is our default consumer protection regulator in the United States. They enforce a variety of specific privacy laws, but they also have this broad authority to go after unfair and deceptive commercial practices. And they have used that authority over the past 30 or 40 years to go after companies for their privacy and security practices by going after statements they make about either privacy or security, or going after companies for times where their security is just so bad or their data collection is just so invasive that it causes an inherent harm. And the nice thing about the FTC is they have a public listed database of all of the cases that they've brought publicly, and they tag that database. And so we were able to go through and look at between January of 2017 and in the summer when we stopped collecting this data, all of the cases that they had tagged as privacy and security. We supplemented it with some other cases we found that we thought should have been tagged from their data set but weren't. And altogether, we found 102 different cases that were in this sort of general category. Now, every case starts with a complaint, and at the back end of a complaint, it'll actually go count by count. It'll name all of the discrete things that the software company did wrong, and so we decided to look at all the counts as well. 322 of those. We then omitted the ones where there was no investigation required. So one way you can violate some privacy laws is just by failing to file some certain necessary paperwork with the government. Don't really need to investigate anything to know that that's true. And so we decided to look instead just at the 283 counts that required some investigation. And then, painstakingly for all of these, we tried to figure out how the FTC figured out that there was a problem. That is, how did they first learn that there was some sort of issue with this company? And what we found that is across the entire FTC corpus that we could build during this period of time, 26.5% of these counts, the FTC learned about the issue thanks to independent research. For about 10% of those counts, we can actually draw a direct link. That is, the FTC is citing a specific piece of research in their complaint. There's one from Consumer Reports on the far left there, for example. And then for some others, we could sort of draw a link because they cite the press more generally, and we could figure out who they were talking about, or there was a prominent piece of news reporting that times out correctly. If you go into the website, you can see exactly how we sort of coded these things. It's at the very bottom of that page is our sort of coding methodology. And actually, you know, this 26% we think actually understates the phenomenon, because if you think about it, each of these cases has multiple bad things that a company was doing. And so a real way to measure this impact, we think, might be to think about the number of cases where at least one of the counts was coming from independent research. Our theory being the FTC learns about it from some public reporting, from some independent research, then uses its discovery resources to go after the company and learns other things as well. And so actually, if we look at that, we see over a third of the FTC's activity across the entire domain of consumer privacy and security owes at least one count to independent research. The impact of this is actually quite profound. Yeah, these are much bigger numbers than I think we expected to see. This is quite significant. And what was interesting, the data is kind of rich. We had a chance to dig into it a little bit. And one of the interesting things that we found is that the more that the FTC was looking at specific software behavior, the more pronounced this independent research became. So where we started to see the influence grow from a quarter to 40% or 50%, or even in one case, 2/3 of all cases, is in situations where you had to sort of get in a little bit to what the software was doing and compare it to what the company claimed the software was doing. So the category that has the biggest impact here, Section 5 is the FTC's general unfair and deceptive authority. They were going after what they call deceptive failure to disclose. That is, the company was disclosing one way that they were sharing data, but omitting another way that they were using or sharing data. Those cases, we see 2/3 of cases being informed by independent research, which kind of makes sense. It takes an expert to kind of dig dig into those things to see what's going on, where you don't see this necessarily with billing behavior, another area where you see a lot of deceptive claims, because a consumer themselves will know if what they're being charged is different than what they told they were being charged. You don't need the expert analysis in the same way. And the other important thing we see in this data is who. There are a lot of different actors out in the world that are feeding into this information ecosystem. Journalists and media organizations are an enormous part of this, both in terms of doing their own work and promoting the works of others. But we see people in industry, in academia, we see journalists, we see people just out there in the world doing this for the sake of doing it. I think number 2 on the list here is unaffiliated researchers. And so for us, this actually gives us a clue into solutions as well. If we're thinking about solutions here, we can't just be drawing a safe harbor or some sort of protection that only protects journalists or only protects academia. We have to be protecting the activity if we want to cultivate it.
Okay, so given all this information, where do we go from here? Let's actually just review what we know. We know 3 things. First, that the economics literature illustrates that we need to actually ameliorate these information asymmetries. And 2, that the legal regime appears to rely on public adversarial testing. And 3, that adversarial testing is just not protected, or at least not actively protected. This leads us to sort of a doom principle in security economics, which says that when researchers lack a positive right to conduct adversarial permissionless analysis, software vendors' dominant strategy may allow users to suffer, and in fact drive good products out. So how do we solve this? Well, first, we can fix the legal literature's bad assumptions. If you actually look at what the legal literature actually says, reverse engineering's purpose is largely to provide interoperability or create a competing product or this sort of nebulous freedom to tinker, freedom to mess with stuff. I will tell you, I have been a reverse engineer my entire career. I have never reverse engineered for any of these purposes. So the argument here is reverse engineering provides a public good, and the law should treat it that way. 2, we need to ban private contract restrictions for crucial tech. So for example, right now, you cannot go out and buy a voting machine. That is not a thing you can do because there are contracts between the voting machine company and the jurisdiction that's purchased them that say that you're not allowed to reverse engineer it and they're not allowed to resell that product. You're also not allowed to go out and buy a rootable iPhone right now. You can sort of loan one from Apple if they so deem that it's okay for you to do that, but then you also have to sign a contract saying that you're going to reveal it to them and all this other terms and conditions. So that's also not cool. And finally, there are things that you just can't buy in general that are things like sentencing guidelines. So this is the Compass case company, if you're familiar with that. And finally, we have to move away from gag orders and bug bounties. And this is my sort of like treatise to you all as part of the security community. Thank you, Katie Mazuris. If you do see one of these disclosure policies in a bug bounty, my recommendation is don't participate, because they're not going to resolve the information asymmetries in the market. You are not actually doing good for the humanity. You might be doing good for your pocketbook. So what they're buying when they actually pay out on one of these things is not the bug, they're buying your silence. So in conclusion, right, what we've done here is we've provided a definition for what kind of economic good security in software is. We provided a bunch of empirical data on the FTC's reliance on independent research regulation. We found that over a quarter of all investigated counts are reliant on independent research. And finally, we articulated a series of straightforward things for a regulatory agenda for improving accountability-oriented independent research. If you'd like to contact us, our emails are up here. Please take a look at our data. We're releasing this data ahead of other publications that we're planning on doing, so if you find bugs, we want to hear from you. If we missed stuff, especially, we also want to hear from you. So feel free to reach out.
Thank you. Thank you.
All right, any questions? I'm being told to stop. Does that mean I can't have people ask questions or no? Can't hear you.
Cool. We'll also hang out here if you have other questions.
Yeah, come talk to us.